Hi everyone! Alright, today we are going to learn about the rules of exponents. So you might have heard about the laws of exponents instead of the rules of exponents. It's the same thing. There are 8 rules or laws of exponents and we're going to learn all 8 today. And guess what? Someone might not have told you this before, but sometimes in math you actually have to study, because if you just get these in an exam, they're not going to give you these rules again, okay? So I'm going to explain how each rule works, and then you have to go and you have to actually study them. I know, it sucks. You thought, oh, math, the one subject where you don't have to actually study. Yeah, sorry. So rule number 1 is the product rule. Basically what this tells us is that you've got a base. In this case, the base is a, and it's raised to the power m, times a, the same base. In this case, it has to be the same base, okay? A to the power n is equal to a to the power n plus n. So we don't multiply the powers, we have to add them. And here is our example today. So x to the power 4 times x to the power 3 is equal to x to the power 4 plus 3, which is x to the power 7. So if you wrote x to the power 12 because you multiplied the exponents, no, that's not correct, okay? So that's the rule, and if you know this rule, you'll know how to apply it, okay? Next rule is the quotient rule, okay? So in this case, you have the same base again, but you are now dividing instead of multiplying. Okay, so a to the power m divided by a to the power n is equal to a to the power m minus n. Here's an example. Y to the power 8 divided by y to the power 3 is equal to y to the power 8 minus 3, which is equal to y to the power 5. Okay, so you don't try and divide the powers. Next rule is the power of a power rule. Okay, so now we are raising one exponent to another power. And in this case, this is where we actually multiply. So previously we had to add because we were just multiplying, but now we're raising a power to a power. So now we have to multiply them. All right, here's an example of how that would work. B to the power 2 to the power 3 is equal to b to the power 2 times 3, which is b to the power 6. Okay, once you know the rules, it's very easy to apply. Rule number 4, power of a product rule. So we had power of a power, now it's power of a product. The product is inside of the brackets or parentheses. The product in this case is AB, A times B. And that is raised to a power by the exponent m, but that means that everything inside the brackets, both a and b, need to be multiplied by the exponent m. So we don't say ab to the power m, we say a to the power m times b to the power m. All right, here's an example of that. 2 times 4 to the power 2. So we raise the 2 to the power 2 and we raise the 4 to the power 2. Then we simplify it. 2 to the power 2 is 4, 4 to the power 2 is 16, and then when you multiply those, you get 64. Okay, next rule, or the next law, okay? The power of a quotient. So now we got a quotient inside of the parentheses, and again, it just means that both have to be raised to the same power. You can't just raise the a to the power m and not do the same to the b. What you do to the a, you do to the b. Okay, here's an example of that. 3 over 4 to the power of 3, so 3 to the power 3 over 4 to the power 3, and then you just simplify both of those, so then it becomes 27 over 64. All right, number 6, the zero exponent rule. This one's super easy. If you see this, you're going to immediately know what to do once you know the rule, okay? It just means that everything to the power 0 is equal to 1. A to the power 0, 1. 100 to the power 0, 1. Anything to the power 0, 1. 17 to the power 0, 1. Easy peasy. Rule number 7 is the negative exponent rule. All right. We've got a to the power m is equal to 1 over a to the power m. So imagine that you're always working with a fraction and there's an invisible line in the middle, okay? So if it's a negative power at the top, it's going to be a positive power at the bottom. If it's a negative power at the bottom, it's going to be a positive power at the top. This is going to count for any fractions that you work with. Here's an example. So now we can see both sides of this applied, basically. So you've got 4 to the power negative 2, which means that it's going to be 1 over 4 to the power 2. And you've got 6 to the power negative 3 underneath the line. So we've got that as our denominator, and then it becomes a numerator. And then we just simplify it. Make sure you simplify it to its absolute simplest form, like we did here. And that's just what you do with this rule. Okay, so rule or law number 8 is the fractional exponent rule. Okay, this one looks very scary, but it's really not. Okay, for this one, it's the first time that we are bringing in a root. You've got a to the power m over n. Anything that's an exponent in a fractional form becomes a root. That is how you simplify it. So it will be the same as the nth root of a to the power m. Right, here's an example of how that would work. So you've got 3 to the power 5 over 2. Then it becomes the square root of 3 to the power 5. And we don't usually write the 2 there. I just kept it there to make everybody understand why it ended up like that. Okay. And then you just simplify what's inside of the root. And you can further simplify it on your calculator, but that is not going to simplify into a rational number, so you just sort of round it off. Okay, let's just go over the 8 rules again, but for you to fully understand them, I would highly suggest that you go practice some problems with these in them, and then also that you actually memorize them, because once you've memorized them, you're going to know them all the way through high school and university and everywhere where you're going to need to work with exponents, basically. So yeah, definitely go study these and let me know if you have any more questions.